My name is Cameron Homeyer. I'm an assistant professor here in the School of Meteorology, and I currently teach two classes during the academic year. In the fall, I typically teach graduate cloud and precipitation physics. So the graduate students learn about raindrops and snowflakes and lots of other processes that take place within those clouds. And in the fall and the spring, I teach our two-part senior capstone research class, where students get to learn the research process and get to work and design their own research projects. I'm originally from Texas. I grew up in the Valley of Texas. I was born in McAllen. I moved to Louisiana for several years during early years of my life, and then moved back to Texas, north of Houston, in a little town north of the Woodlands in Texas there, and decided to go to Texas A&M for my college experience. So I went there, got my bachelor's in meteorology, and stayed there for graduate school, and then somehow ended up here several years later. When I finished my undergraduate degree, I knew, the only thing I knew and felt very strongly towards is that I was really passionate about research. I decided to go to graduate school, stayed there at Texas A&M, and studied a lot of atmospheric transport, how air moves around in the atmosphere and really on larger scales. So you take air from the United States and how it ends up halfway across the world several days later. And as I went through graduate school, I also discovered that I was really interested in mentoring other students and mentoring others, both within my research group and there at the university, on their projects. And I got really interested in advising students through research and just the research process and helping to share the things that I learned along the way. So I felt this really strong pull towards academia. And I left graduate school, went into a postdoctoral fellowship position for 2 years. And it was really clear to me at the end that I wanted to both have that research and teaching experience be a part of my career after that. And coming to University of Oklahoma and being an assistant professor here in the School of Meteorology was a great opportunity for me to accomplish. Our research group here at the University of Oklahoma is called the Convection, Chemistry, and Climate Research Group. That's the group I head. It comprises about 5 graduate students and 3 undergraduate students currently, also involved in other activities that extend beyond my personal research group. But what we study here in my group are processes that connect weather, chemistry, and climate. So for example, we tend to study a lot of the same storms that people are concerned about for severe weather, but instead of looking down near the surface, we look really high up in the atmosphere. We're interested in the air that's getting lofted within these storms and transported to the upper atmosphere. So we focus a lot on radar meteorology. We use the same precipitation radars that we use to track the weather here in the States and what's going on down near the surface in terms of heavy precipitation events and so forth. We can see the complete three-dimensional structure of the storm. So we use a lot of that radar data to look at the physical characteristics of these storms, how tall they are, how deep they are in the atmosphere, and then how that corresponds to their ability to transport air. In addition to radar meteorology, we also focus on processes near the tropopause, so this boundary between the layer of the atmosphere we live in, the troposphere, and the layer immediately above that, the stratosphere. And this area of work is called upper troposphere, lower stratosphere studies. There are many things we're interested in when it comes to that. And finally, on the climate side, in addition to looking at processes that sort of touch on all 3 of these, both radar meteorology, upper troposphere, lower stratosphere, and climate, we are really interested in how some of these radar meteorology and UTLS studies sort of translate into climate studies. So how the altitude of the tropopause changes over time, or how the characteristics of storms change in a warming climate. So that's how we fold all 3 of these areas together. But our projects really focus